Sathyabama Institute of Science and Technology.
Hi, energetic learners. Wish you all a very blessed day from Dr. A. Viji Amutha Mary, Professor, Department of Computer Science and Engineering, Sathyabama Institute of Science and Technology. Welcome you all back to this video lecture on optimal merge pattern problem. Let's discuss the objective of optimal merge pattern problem. The objective is to merge a set of sorted files which are of different length into a single sorted file. So when you are merging two or more sorted files into a single file, the minimum computations that are done to form the single file is known as the optimal merge pattern problem. So when you are combining two files, when you are merging two files of different sizes m and n, the total number of computations will be m and n. Let's go to the example. So here we take the inputs n and size. So here n equal to 3, which denotes the number of files, and the size of each of these files are given in the array, that is 2, 3, 4. So the size of the first file is 2, and that of the second file is 3, and that of the third file is 4. Okay, now we are going to solve this optimal merge pattern problem by different methods, and then we are going to come to a conclusion. Okay, so method 1. Okay, let's discuss method 1 first. So here we are taking the files as such in the given sequence and we are merging the files. So we are merging the first file which are of size 2 with that of the second file which is of size 3. So we merge the first two files. So the number of comparisons that is done equal to 2 plus 3, which is equal to 5. So now we have got a resultant file now. So we are going to combine this resultant file with the third file which is of size 4. So now the total number of comparisons will be 5 plus 4, which is equivalent to 9. So now the cost incurred is equal to the total number of comparisons that are taken here in method 1. So the number of comparisons that are taken in this method 1 are 5 plus 9, which is equal to 14. Okay, now we are going to solve the same problem with another method. Okay, now we'll discuss method 2. We are merging second file and third file. Okay, so the second file is of size 3 and the third file is of size 4. We are merging these two files first, and the number of comparisons that are done is equal to 7. So we have got a resultant file now. Now we are going to merge the first file with this resultant file. So now the number of comparisons taken is 2 plus 7, which is equal to 9. So the cost incurred is equal to the total number of comparisons that are done in this merging operation. So the total number of computations that are done are 7 plus 9, which is equivalent to 16. Okay. So there is also another method of solving this problem. We'll also discuss that method. So here we are taking the first file and the third file. We are merging these two files. So the number of comparisons that are taken is 6. That is 2 plus 4, which is equivalent to 6. Now this resultant file is combined with the second file, which is of size 3. So 6 plus 3 will be equal to 9. Now you add the total number of comparisons that are taken, that is equal to 6 plus 9, which is equal to 15. So now let us compare the cost that are computed in all the three methods. So in the first method the cost incurred is 14, second method gives the cost as 16, and the third method gives the cost as 15. So here the optimal cost is 14. So that is the optimum solution. So the optimum solution is method 1. So first we arrange the files in the increasing order of size. Okay, that is 2, 3, 4. But in this example already the files are given in that increasing order only. Okay, so when the files are given in different size order, first you arrange it in increasing order of size. Then you merge the smallest two files first. Okay, the files which are of smallest size, that are taken and that are merged. So here 2 and 3 are merged. The number of comparisons is 5, This resultant file is again combined with the another file, the next small file, that is 4. So the number of comparisons that are taken is 9. You add all the number of computations done, so that will be the total cost. So that is 5 plus 9, which is equivalent to 14. So actually here we are solving this problem by greedy approach. So as we all know, the greedy approach solves the problem by taking locally optimal choices at each step and finally coming to the optimum global solution. So here we are following the greedy approach. We make the best choices at each step and finally we are coming up the optimum solution. Let's take another example so it will be easy for you to understand. So here 5 files are given with different sizes, F1, F2, F3, F4, F5. So the sizes are also given. So first let us solve the problem in the given sequence, and then we are going to solve by greedy approach, and then we are going to compare the cost, and then we are going to come to a conclusion. Okay. So if the merge operations are performed according to the given sequence, so first we will be merging F1 and F2. So the number of comparisons will be 20 plus 30, which is equivalent to 50. Then we merge this resultant file with the next file in the sequence, that is F3. So the number of comparisons will be 50 plus 10, which is equivalent to 60. Now again merge this 60, okay, that is this resultant file with the next file in the sequence, which is F4. So 60 plus 5 will be equivalent to 65. Okay. Then again merge this M3 with the next file in the sequence, that is F5. So here the number of comparisons we got is 65 plus 30, which is equivalent to 95. So the total number of computations or the total number of operations that are done is, just add all the operations. Okay, just add all the comparisons that are done. That is 50 plus 60 plus 65 plus 95, which is equivalent to 270. So 270 number of comparisons are done when you are doing by this method, by method 1. Now we take the next method. We are going to solve by greedy approach. First we sort the file in the increasing order of their size. So we get this sequence F4, F3, F1, F2 and F5. Now we are going to perform the merge operations. Okay. So first merge F4 and F3. The number of comparisons will be 5 plus 10, which is equivalent to 15. Now we are going to merge this M1 with F1. So the number of comparisons will be 15 plus 20, which is equivalent to 35. Then merge this M2 with F5. The number of comparisons will be 30 plus 30, which is equivalent to 60. So now we are merging M2 and M3. The number of comparisons will be 35 plus 60, which is equivalent to 95. Now the number of computations that are done is 15 plus 35 plus 60 plus 95, which is equivalent to 205. So which is the optimum one? Which is the optimal method now? You compare the number of comparisons that are taken in method 1, that is 270. Here we get only 205. So the optimum method is the second method, which is the greedy approach. Now let us devise an algorithm for the intermediate node. We are merging the two files and we are getting an intermediate node. So for that we are going to write the algorithm. So declare the new node first. So take the minimum size file from the given list, and that should be the left node. The next minimum size file will be taken as the right node, and the intermediate node weight will be the sum of the left node weight and that of the right node weight. Now insert this new node into the list. So this is a small algorithm for that new node, okay, for declaring the new node, for inserting the new node into the list. The merging operation is very clearly explained via this diagram. So the inputs are given. These are the 5 different files with varying sizes, 5, 10, 20, 30, 30. So the files are arranged in the increasing order of size. So in step 1, we merge the smallest size files and we are getting a new intermediate node 15. That is 5 and 10 are merged and we are getting a new node 15. So the weight 15 is got by adding the left node weight and that of the right node weight. 5 plus 10 equal to 15. Let's go to the next step. Now the next two small size files are taken and they are merged. So the next minimum size files are 15 and 20. So these two files are merged and we are getting a new node 35. So in the next step, the minimum size files. So the next minimum size files are 30 and 30. So these two nodes are combined and we are getting an intermediate node 60. So in the next step, we are combining 35 and 60 and we are getting the root node 95. So we add the total number of comparisons that are taken, and that is the optimum cost, which is equivalent to 205. So thank you learners for listening this video very patiently. We'll meet you again in the next video lecture to quench your knowledge thirst. Thank you once again.